Awesome. Hello. My name's Stefan. I'm the CEO of a company called Dagworks, but I'm not going to sell you anything today. I'm going to talk about an open source project I created at Stitch Fix. It's called Hamilton, and it's a Python micro framework for describing data flows. The thing that I kind of want to leave you today is, hey, if you're building large language model powered apps, I think Hamilton is something you should add to your tool belt to help you build it. So, to set some context, two things, getting these LLM-powered apps to production, I hear is a bit challenging and a bit tricky, right? Two things that I kind of hear most common is, hey, observability is tough, and then this kind of impacts iteration and debugging, where I know people could spend a lot of time, figuring out what happened just because the iteration and changing things in production is difficult. My take here is that it's a software engineering problem, in that you need to engineer things in a way to provide you the hooks for observability, and you got to write code in a certain style that's amenable to make changes quickly, confidently, so that when you make changes, you don't break things easily. In short, the high level is, I think, Hamilton can help you here, especially if you're rolling your own code, which I hear most people are doing if they're taking their apps to production. So why does Hamilton help in this context? So most large language model powered apps are largely just a sequence of data flows, meaning you have data and you're transforming it. And so you generally have an agent which contains the state of the conversation, but then it's taking some sort of actions. And what I mean here by sequence of data flows is really these actions. So if you want to find articles or summarize articles or something, you can model that individually as data flows, or directed acyclic graphs if you study computer science. This is Hamilton's bread and butter. And so what I'm talking about is you should consider using Hamilton to help model the actions. What is Hamilton? This is a lightning talk, so this is going to be brief, but Hamilton in a nutshell is a paradigm. It's a slightly different way of writing Python code. You write declarative Python functions, and they give you a data flow or a DAG. Here I've defined two functions. The way to read it is I have the first function defines an embedding. The embedding requires a query and outputs a list of floats. And then I've defined another function that gives me the nearest neighbor IDs. That takes in embedding, it takes in a vector DB client, and then the top K result, top K number. Here with Hamilton, what we've actually defined in code with these functions is this following data flow. You can kind of see that query is required for embedding since it's declared in the function, and then nearest neighbor ID similarly declares three things, and you can see that represented in the function arguments. One way to think about Hamilton is that if you were to draw a flowchart of a sequence of computation, it is the most direct way that you could write that in code, where effectively any node of computation you can write as a function. And by the way, I didn't hand create this image. This comes with Hamilton for free. So it's a great way to also bolster your documentation. Now, why should you use Hamilton? Well, I think it'll increase your iteration speed, give you clarity over your code, and also increase your testability. Every function in Hamilton is unit testable and it has a great integration testing story. But more so when you're making changes, you don't have to deal with object-oriented hierarchies. No need to kind of understand and really dig into something. So here I have an example. So if I really just want to abstract out using the OpenAI client, all I need to do is change the signature of a function. It's very clear what I've changed. And then structurally, you can also see that represented in the graph that's kind of defined. The other is around modularity and composability. This data flow here, we can easily add it to a different workflow pretty easily just by declaring a function that depends on it. And so it's very easy here, for example, to reuse and compose workflows in a modular way. So in this top flow, I was getting the nearest neighbor IDs given an embedding, and I just connected it to another flow that is getting, say, the relevant documents, connecting it with a tokenizer and chunking it. This means, and so getting to the iteration aspect, it's very easy to switch between multiple implementations. You want to switch vector databases, you want to switch between different LLM APIs. Part of what Hamilton gives you is it can be very surgical about it. you can very easily change different node implementations, or even just cut the data flow and switch that out with a completely different implementation, and that's very clear and easy to do with how you kind of define the code. So this is a lightning talk, so I'm going to try to summarize this and kind of leave you with a few takeaways. So first is that Hamilton is a way to write Python functions in this kind of declarative manner. What you get is a data flow. And what I'm telling you, saying that it's good for in that context of LLMs, it's a great way to model the different actions that you need it to take. So this means I think you can iterate faster and have a clearer testing story. And similarly, if you pair this with Git, when you change your app, you can always go back in time to understand how a particular flow worked very easily. It has a very lightweight dependency footprint, runs anywhere that Python runs, Jupyter, Airflow, Fast API, etc. There's a lot I haven't shown you, and it's actually built to be extended. I was on the platform team at Stitch Fix, so we built this to be, to make an easier life for a platform team. And so if you need to add caching, which is one of the things you want to do to save costs, or if you need to, emit different kind of observability, the framework is extensible and easy for you to add this kind of functionality to it on top of your Hamilton data flow. And then lastly, Hamilton is not only for LLMs. You can use it to model any data flow. So if you're doing traditional data processing or feature engineering or model pipeline, Hamilton can be used for that. And so why add more tools when you can kind of consolidate on one? In short, just to summarize, thanks for listening. If you want to get started, you can scan the QR code that will take you to the GitHub page. Would love a star. It's on, you pip install SF Hamilton. You can be up and running in less than 15 minutes. If you want to go ahead and try Hamilton now, you can go to tryhamilton.dev. It's running Pyodide in the browser. And otherwise, we have a community on Slack. And if you want to reach out to me or have questions, I'm more than happy to chat to you. And otherwise, if you're interested to know what I'm actually building at DagWorks, feel free to sign up. Happy to chat about that as well. Thanks for listening.